All right, so now we're really going to do the worksheet. Okay, so where is 7 pi over 4? So if I look at my document here, or if I just look at the angle, 7 pi over 4, I'm going to look at the pattern. If I double the denominator, that makes 8, and then I subtract 1, that gives me 7. That was the rule for the fourth quadrant, okay, because we're going to 2 pi and then subtracting 1 out. I'm going to double check. Yes, the purple is 7 pi over 4. So this is in quadrant number 4. Okay. Next one, 11 pi over 4. Now this one is not in, we have pi over 4, 2 pi over 4 is 90, 3 pi over 4 is 135, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, and that makes 2 pi. So 11 pi over 4 is more than one full rotation, so we just keep adding quarters. 8, 9, 10, 11. 11 pi over 4 would be in the second quadrant. Okay, so I can count it that way. Or what I can do is take 11 pi over 4 and subtract out 2 pi, which gives me 11 pi over 4 minus 8 pi over 4, right? That's 2. 8 divided by 4 is 2. That gives me 3 pi over 4. So if I subtract out a full rotation, it'll also tell me, help me figure out what a coterminal angle is. So an angle that ends in the same place. So 11 pi over 4 and 3 pi over 4 end in the same place but have a different number of full rotations. Coterminal angle. That was in your vocab from last week. Okay, -1. Is this radians or is this degrees? If it does not have a degrees symbol on it like this, then it is in radians. Do you remember how many radians are in a circle? Yeah. Okay, there are 2 pi rads, 2 pi radians, or about 6.28, 3.14 times 2. Okay, so think on the top half of the circle, I'm going to add another page here. Okay, top half of the circle, around the crust, there are 0 to 3.14 radians. Bottom half, to complete the circle, is greater than 3.14 to about 6.28. So where is -1 radian? Negative radians, let's add another line. Negative radians are open, well, it's backwards, okay. Open clockwise. So I'm going to start with my initial side on the x-axis, and then I need to spin clockwise, and I can see that 1 radian would be in the first quadrant somewhere. First quadrant. Okay, so this is the first quadrant. Okay, where is -2 radians? Okay, if I know that from 0 to 3.14 is from 0 to 180 basically. So what is this is 3.14 divided by 2, which is 1.57. Okay, so if I move, I think this one's negative as well. Yeah, negative. So we're going to open in the clockwise direction, and are we going to go past the y-axis or before the y-axis? We're going to go past the y-axis because here would be -1.57, but it's less than 3.14, so we're going to end up in the third quadrant. I said this wrong. This is in the fourth quadrant. That's the 6th. The fourth quadrant. If you go back again, remember we opened up this way to the fourth quadrant. Okay. All right, 150. That is top half the circle, which more than 90, less than 180. So we're going to be in the second quadrant. Okay, 284. All right, so in degrees, this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then back to 360, and we can continue on in the circle like that. So 360 plus 90 would be 450 degrees. 90 and 450 are coterminal angles. They end in the same place, but they have a different number of rotations. Okay, this would be 540 degrees, 630, and then 720. So all these 0, 360, and 720 are coterminal angles. So on the circle, they're graphed the same, but again, they have a different number of rotations. Okay, so back to our problem, 282. That looks like it's greater than 720, but less than 360. So our angle is going to be in quadrant number 4. Okay. Sketch the angle in the standard position and state the reference angle. All right, so we're going to divide by 3s. So I know that I'm going to cut, there's actually 6 wedges. That's double what you think, okay? Remember, it's 3 wedges on the top. So I'm going to cut this circle up into 1, 2, 3, 4, 5, 6 wedges of 60. Okay, and I can see that the numerator is 1 larger than the denominator, so that should be in the third quadrant. So I'm going to count 0, 1, 2, 3, 4. My angle is the x to the terminal side. So the angle here, theta, is equal to 4 pi over 3. Now the reference angle, I'm not sure we went over this in the last vocab section, so here we are. The reference angle is the acute angle that connects the terminal side to the x-axis. So in this case, our angle is in quadrant number 3. We're going to take the terminal side, which is the side in quadrant number 3, and we're going to connect it vertically, always vertically to the x-axis, to make an angle. What is this angle right here? Okay, that angle is our reference angle, which we call theta prime, and it is the same, it's basically pi over 3. It's one wedge. Remember, it's one wedge past the x-axis, so it's going to have a reference angle of pi over 3. A good trick is the reference angle is always the angle that, whatever the denominator of the original is, it's going to be the denominator of the reference angle. Okay. The next one, negative 7 pi over 4. So this time we're going to start on the x-axis, and we're going to move clockwise instead of counterclockwise. We need to split our angle up into fourths. So 1, 2, 3, 4 on the bottom, and then 1, 2, 3, 4 on the top. All right, our angle starts on the x-axis, and then we're going to count 7 fourths around. So 1, 2, 3, 4, 5, 6, 7. We're going to end up right there. Okay, right there. And it moves this way. So our theta is equal to negative 7 pi over 4. All right, take our angle and connect it back to the x-axis. What angle is this? Again, our original angle divided by 4, so our reference angle is going to be over 4. It's pi over 4. Okay. All right, last one. 4 radians or degrees. Remember, this is radians because there is no degrees there. So 4, we're going to start on the x-axis, and then we're going to move counterclockwise in the positive direction. Where we started with an angle of 0. This is 1.57 radians, 3.14 radians, 3.14 plus 1.57 is 4.71. So 4 would be here in the second quadrant. Okay, so theta is equal to 4. So if I connect back, to the x-axis, what is this angle? Okay, and all we need to do is take our 4 and subtract out the top part, this part, which is pi, minus pi, and we just leave it like that. It's exact. We like the exact. I guess I can get a decimal equivalent. So 4 minus pi would be 0.85. And I put the dot, 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 so I didn't round. Okay. Next section. Coterminal angles. This was in your vocab. So again, it's in the same, the angle on the unit circle will be the same, have the same initial and terminal side, but a different number of rotations. So we're going to do this. Let's do 114 first. Okay. So I'm going to go ahead and use my paper on the side. I'm sorry this video is long. It's confusing. Okay, so on the unit circle, we're starting, or on the circle, we're going to start at the x-axis, and then we're going to open up to 114. So this is 0 degrees, 90 degrees, 180 degrees, and 270 degrees. So I'm going to open up past 90, but before 180, so about right there. So this is theta is equal to 114 degrees. Okay, so what if I just added in a full rotation here? So I took this arm and I spun it all the way around and just made it land at that same exact space, but I turned around one extra time. It's like if you're a figure skater and you turned around in the air one extra time. You'd have a different trick, but you'd face the same direction in the end, right? Yes. So to get a coterminal angle, you just add or subtract 360 degrees. So we're going to add or subtract 360 degrees to our angle. So I'm going to start with theta, and I'm going to add 360 degrees. So I get 114 plus 360, make sure you use your degrees, is 474 degrees. So this is one coterminal angle. It asked for a negative coterminal angle. So this time I'm going to take this arm, and instead of continuing on in the counterclockwise direction, I'm going to spin it back counterclockwise direction. So I'm going to unwind. So this time I'm going to take my theta and I'm going to subtract 360 degrees. So 114 minus 360 is negative 246. We could do this for days. Okay, here's another coterminal angle. Negative 246, and I subtract another 360 degrees. Negative 606 degrees. There are an infinite number of coterminal angles. Okay. All right. So we have a positive one of 474. And a negative angle of negative 246 degrees, or if you put negative 606 degrees, that's okay too. I would take either of those. Okay, so negative 9 pi over 4, I'm going to sketch out what that looks like in just right here. Okay, so over 4 would be cutting the top up into 4. So 1, 2, 3, 4, and then the bottom into fourths. 1, 2, 3, 4. So I should have 8 chunks in total around the circle. Am I going to move in the clockwise or the counterclockwise direction? We're going to move in the clockwise because it's a negative angle. And I'm going to move 1, 2, 3, 4, 5, 6, 7, 8. That's a full rotation, plus one more, 9. Okay, so I have an angle right here of, I went 1 and a little bit of negative 9 pi over 6. So I'm going to start with my angle, negative 9 pi over 4, not over 6. Okay, and I'm going to subtract out a full rotation, which is 2 pi. So basically, I'm just going to take this arm and I'm going to spin it around another time, which is my negative 2 pi. So negative 9 pi over 4 minus, let's see, multiply by 4 gives me 8 pi over 4. Add those together, 16, 17, negative 17 pi over 4. That is a coterminal angle, a negative coterminal angle. How do I get a positive coterminal angle? All right, I'm going to go back to my drawing here. Go back to the drawing board. Okay, I have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I'm going to, again, my angle is right here. I don't know why I did those wedges again. And so I started off by going negative 1 and a little bit, negative 1 rotation plus 1 extra wedge. This time, I'm going to add back, so going in the counterclockwise direction, I'm going to add back 1 full rotation. So I'm going to do negative 9 pi over 4 plus 2 pi, since I'm moving in the positive direction. So we can convert 2 pi to 8 pi over 4. I'm going to add those together, and that gives me negative pi over 4. That is a coterminal angle, but the problem is that it's still negative. So what can I do to get another coterminal angle? Guess what? We just add another 2 pi. So I'm going to take negative pi over 4 and add 2 pi, which is negative pi over 4 plus 8 pi over 4. So negative 1 plus 8 gives me a positive 7 pi over 4. I wrote that down. 7 pi over 4. And I can see when I take away all of this mess, all these rotations and whatnot, okay, this angle right here, if I go like from the 0 and move counterclockwise to this side, this would be 7 pi over 4. So it looks, even though the initial side and the terminal side end up in the same place, but we got there basically by spinning a different number of turns or going in a different direction. Okay. Last part. We're going to convert between degrees and radians. So for radians, I'm going to start with my negative 4 pi over 1, basically. And I want to convert this to to degrees. This is just like chem. It's just a unit conversion. What do you call those? I don't know. It's escaping me right now. Okay. So I know that pi is equal to 180 degrees. So I want degrees. I'm going to put 180 degrees on the top. And I want to get rid of or cancel out the pi part or the radians part. So this is my unit conversion. It is 180 per pi. Okay. So I notice that my pi's cancel, and then I'm just multiplying 180 times 4, which is equal to negative 720 degrees. So negative 4 pi is equal to negative 720 degrees. Okay, 150 converted into 150 degrees converted into radians. And then we also are going to get a decimal equivalent for that. Okay, so 150, we multiply it by our unit conversion. This time I want radians, so I'm going to put pi on top, and 180 degrees goes on the bottom. Cool? Cool. Okay, So we are going to end up with a pi in the end. So 150 divided by 180 is 5/6. So this is 5 pi over 6. Let's convert that. You do that by doing 5 times pi over divided by 6, basically. Okay, so I do 5 times pi, then divide that by 6, and that gives me about 2.618 radians. We don't ever write it, but I'll just write it right there for you. Radians. Okay, that's what you're in charge of. Let me know if you have questions. I know this is crazy. Just let me know.